All right, so chapter 10. We're only going to do section 1 today, and then we will finish it out next week. Compound interest. All right, so we're used to finding simple interest at this point, which is principal times rate times time. But we also have to consider when we're dealing with interest rates that are being compounded many times during the duration of the loan. Okay. So, what we need to worry about is present value, which is the value of an investment today, as in right now. Future value, future amount, or compound amount, which is the amount in an investment at a specific future date. So, future values depend on compound interest. Compound interest results in a greater value than simple interest. So, if you are going to open up a savings account, um, I am not in the position to have a really great I have a really great savings account, but I'm not able to have like an awesome savings account in the sense that my savings kind of fluctuate because obviously I work, you know, not the most secure environment. I love teaching all of you, but I'm not full time yet. So all the money that I make during the year, I have to save up and then kind of pay myself over the summer because I don't have the same amount of money coming in. So when you are lucky enough, if you have enough money that you can save, you want to try and get savings accounts that have more of this compound interest idea. And what happens is the more money you save, the more money you end up like paying yourself because they will compound your results every so many months or whatever you set it up to be. And then that will go into your account, which is very nice. But again, I don't have that kind of savings. Interest rate is a higher rate results in a greater future value. Length of the investment, an investment held longer usually results in a greater future value. All right. I can tell you that with a simple savings, you're looking at like 1 penny per month per $1,000. That's basically what it works out to be. But don't worry, they still let you know if you take money out too often. Okay, so this is the power of compound interest over time. Um, so obviously, a more simple interest is going to go even slower than this, and obviously, most of us probably don't have $10,000 sitting in the savings account, right? We might have $10,000 in the bank, but you got to add everything up. All right. Compound interest is calculated on previously credited interest in addition to the original principal. Using interest equals principal times rate times time to find simple interest for the period, add the principal at the end of the previous period to the interest for the current period to find the principal at the end of the current period. This sounds really complicated. It's not. We just have to, here we go, get to an example. Regina Foster wants to compare simple interest to compound interest on a $2,000 investment. Find the interest if funds can earn 6% simple interest for 1 year, if they can earn 6% interest compounded every 6 months for 1 year. Find the difference between the two and find the effective rate for both. Right? A simple interest on $2,000 at 6% for 1 year is as follows. And you guys know how to do this part, okay? Original principal. Here we go. And then you add it up, okay? Now, here's where it gets a little different. The interest for the second 6 months. So did you see that? For the first 6 months, it's the same. Well, I guess it's half. Okay. And then here's for the second 6 months. Notice that they had to use the different principal. So then they end up with this. Okay, so that's greater than the first time, which makes sense because your original principal went up. So here the difference is not that much. It's $1.80. But you can see that if you had more money and or more time, that small difference can get very big very quickly, right? Okay. They would basically be an exponential problem because it is. All right, the effective rate is found as 6.1%. If it's compounded. Okay, 6% makes sense because you knew it was going to be 6%. Although they have the same nominal rate, the compound interest investment has a larger effective rate due to compounding. All right. This stuff is not that hard. When you do the homework, it's going to be pretty easy. If you have problems doing the homework, please email me. I've done all of it, so we can definitely work through them, okay? The Simpsons want to pay $5,000 down in 4 years on a new car. Today they invest $3,800 in an investment that pays 6% interest compounded annually. Find the excess of compound interest over simple interest at the end of 4 years. Will they have enough money to meet their goal? First, calculate interest. Find the, I'm going to guess I think this is supposed to go over here. I think it's supposed to say first, calculate interest using I equals PRT. Find the new principal by adding the interest earned to the preceding principal. And there it shows you all that. Okay. So the compound interest, and when you come back here, why are they doing it 4 times? Why are they doing it 4 times? How many years did they want to save for? 4. So that's why they're doing it 4 different times, okay? So then they're going to figure out their simple interest and find the difference. Okay. They will be short of their goal by $202.59. So probably if they saved for another month, they would have had it. I'm sure they will still continue to save until they get their 5,000. I would. The compounding period is the time over which interest is calculated by and added to the principal. The number of compounding periods is the number of compounding periods either in each year or in a life of a loan or investment. The interest rate per compounding period is the interest rate applied to each compounding period. It is found by dividing the annual interest rate by the number of compounding periods in a year. The total number of compounding periods in the investment is the product of the number of years in the term of the investment and the number of compounding periods per year. All of this is just words, guys. Just worry about doing the examples in your homework and you'll understand it. Find the interest rate per compounding period and the number of compounding periods for each. A 5% compounded semi-annually for 3 years, 6% per year compounded monthly for 2.5 years, and 2% per year compounded quarterly for 5 years. You will have to do something like this on your homework. Okay, so semi-annually means how many times in 1 year? If it's semi-annually, how many times would that happen in 1 year?
Twice.
Thank you. Yes, twice. So we're going to take the percentage and we're going to divide it by 2 because it's compounding twice in that year. But then you have to realize that you are going to do this problem for 3 times because it's 3 years. So you're going to take 6 times the 2, which, well, 3 times the 2, which gives you 6. So your compounding periods, there are 6 compounding periods in 3 years. Okay. And that's all you need to find for that one. 6%, you'll divide it by 12 because it says monthly and there are how many months in a year? There are 12 months in a year. So you divide that, you get 0.5. And then to find the periods, you're going to take 2.5 times 12 and you get 30. Okay. For the last one, it's quarterly. There are 4 quarters in a year. Whoops. So 2 divided by 4 gives you 0.5 again. 5 years times 4 will give you 20. You have tables for all of this, so you will be more than fine. The formula for compound interest uses exponents, which is a short way of writing repeated products. You guys know that, yes? This is wrong, by the way. It should be a 3 there. Yeah. Note how they stated it correctly, but that is incorrect. This should be a 3. We'll write it like this. Should not be a 2. It should be a 3. So it should look like this. Anybody else catch that mistake before they decided to not tell you it was a mistake? All right, good. Maturity value is going to be principal times 1 plus I raised to the n. Okay. Initial investment, number of compounding periods, interest rate per compounding period. Note that this is different than your regularly given interest rate. Okay. This is going to be like if it says it's 5% and then you had to divide it by the 2, that's going to be your 2.5, not your 2.5%, not your 5%. Okay. Questions on that? If you get confused on your homework, I guarantee you that's where part of your mistake will be, okay? Let's look at an example. An investment at Bank of America pays 7% interest per year compounded semi-annually. Given an initial deposit of $4,500, use the formula to find the compound amount after 5 years and find the compound interest. And interest is compounded at 7%. It was semi-annually, so you divide it by 2, so that will give you a new little I. Okay, so the little I like that of 3.5 every 6 months for 5 years. So 5 times 2 will give you 10. Therefore, 3.5 will be the interest per compounding period, and 10 is the number of periods. So 10 will be equal to n. So 4,500 times 1.035 raised to the 10th power. So you will have a total of 6,347 and 69 cents. You will have problems like this. You will have to understand where the numbers are coming from. Okay. You go ahead and subtract that and you get an interest of 1,847 and 69 cents, which is great for you. That's almost $2,000 interest. Okay, this value can be found using a calculator or in the compound interest table. You can use either for your exams. Interest rate is at the top of the table and the interest rate per compounding period. Value of n is down on the far left or the far right, so you can use either side of the table, whichever way is going to get you the answer easier. And the body of the table is the compound amount for each dollar in principal. So you have to multiply that. Compound amount is principal times the number from the table. And this is an example of what the table looks like. So when it was 10 times and the percentage was what? 2.5, right? If we would have taken the 4,500, so let's all do that. 4,500 times, where's my mouse? Okay. 1.28008. It's a little bit different of an amount. Did we do that right? Where's that one slide at? Oh, 3.5. My bad, guys. 3.5. Too many numbers going on today. So 10 and 3.5. Oh, we don't have 3.5. That's why they did it by the calculator. Gotcha. All of your homework will give you percentages that you will find in this table. If you can't find it in the table, then it's not meant to be used with the table. All right. So in each of the cases, find the interest earned on $2,000 deposit. For 3 years compounded annually at 4%. For 5 years compounded semi-annually at 6%. For 6 years compounded quarterly at 8%. And for 2 years compounded monthly at 6%. All right, we will find solutions to all of those, and that is probably the last problem we will do, I believe. All right, let's do it. In year 3, in 3 years, there are 3 times 1 compounding variables. The interest rate per compounding period is 4% divided by 1, which is 4%. So if you go to the table, here's 4. You drop down to 3. And you're going to multiply whatever it is by that number, 1.12486. So you take 2,000 times the number from the table, and then you do your subtraction. Same thing here. 10 and 3. So here's your 3, here's your 10. All right, are we seeing how easy the table can be? Just have to use it correctly. All right, again, multiply it by the 2,000, find your difference. This stuff is going to be easy peasy for all of you, right? Here we go again, 24 times, and down the 2 column. Do your multiplication, do your subtraction. Okay, if you need to rewatch this later, it will be up. I will put it up for you. Again, you get this from the table. And do your subtraction. Okay.